Hello students, I am Professor Pooja Paratane from Modern College, Shivajinagar. In this lecture, we are discussing about the examples on formulation of linear programming problem. Linear programming problem is the model in which all decision variables are linear in nature. It contains objective function which is to be maximized or minimized, subject to the available conditions which are called constraints, and last, the positivity constraint. While formulating the linear programming problem, first we have to decide the decision variables. Then, studying the data, we have to find out which are the constraints. Constraints can be related to raw material, then time, demand, or as per the availability, etc. And then finally, we have to identify what is the objective function, what is the goal, whether it is of maximization or minimization. If there is profit, then obviously it is of maximization, and if it is related to the cost, then it is minimization. So let us see the example based on this.
It's a very big example, but if we make parts of this example, it is easy to formulate it properly. Let us read first that example, because firstly, from that example, we have to first decide the variables. We have to identify which variables are there. So let us read this example. A manufacturer produces three models. There are three models, 1, 2, and 3 of certain product. He uses two types of raw materials, A and B, of which 4,000 and 6,000 units respectively are available. So now here I will get some idea that they have given that the raw materials A and B are available. Means this can be constraints. Means this raw materials here, A and B, will form my constraints. Let us see. Means if the raw materials are A and B, so obviously this models, for these models, I have to define the variables. So now let us read the next line, what they have given. The raw material requirements per units for model 1 is 2 units of A and 4 units of B. Those they have given requirement for model 1. Then for model 2 requires 3 units of raw material A and that of 2 units of raw material B. Okay, so also requirement for model 2 is given. And for model 3, whereas model 3 requires 5 units of A and 7 units of B. So here we will just cut it, because this is all information. Here again I will cut it from this side. Okay. If we'll make such parts of the example, it will be easy to formulate it and to identify which are the variables and which are the means how to define the constraints and objective function. Okay. So now here, let us concentrate on this first paragraph. So two raw materials are there, A and B. Their availability is also given. And the requirements of that raw materials in model 1, 2, and 3 is also given. Let us again read next. First, we will try to understand this big example and we'll make first the parts, and according to that, we will decide. Don't decide it before, I mean, first you read the complete example and then only you work on it. Do not do it means immediate, means don't do your immediate reaction and decide these variables. Please read it fast. So uh, now let us read the next. The labor time of each unit of model 1 is twice of model 2 and 3 times of model 3. The entire labor force of the factory can produce equivalent of 2,500 units of model 1. A market survey indicates that, okay, now this is not related with the time, so I will cut it from here. So now this second paragraph gives me some information about the availability of the time. Let us see. So that is my, again, another one constraint, because here some number is given 2,500 units of model 1, they have given some time, so let it be. So that will be my, I think, another constraint. Let us go to the next line. A market survey indicates that the minimum demand of three models is 500, 500 and 350 units respectively. So here also I'll cut this, because this gives me the demand constraint. Here the demand is given for each model. So this line will give me some information. Let us go to the next line. However, the ratios of number of units produced must be equal to 3 as to 2 as to 5. So here this is some relation between them. Here, however, the ratios of the number of units produced must be equal to 3 as to 2 as to 5. So here the relation between the models they have given, that it should be in this ratio. Let us go to the next line. Assume that the profit, now here something word which is related to our objective, here profit word is there, per unit of models 1, 2 and 3 are rupees 60, 40, 100 respectively. So here something I have given here some profit, and here they have given some numbers. So obviously from this line I may get my objective function. So here the question is, formulate LPP to determine the number of units of each product which will maximize the profit. So from this line, I will get my objective function, and whatever information is given above, which we cut in some paragraphs, give me the constraints. So now let us first define the variables, because this is the first step that we have to define the variables. So let us define the variables. Look, so what to define now? We are formulate the LPP to determine the number of units of each product. So now as here this line is given, we can immediately say, but suppose here only the question is that formulate LPP. So we have to decide. So suppose only this line is given, then we have to decide that which variable to be taken and that one. So that is decided from this line. So if you observe this line, that the profit per unit models 1 and 2, 1, 2 and 3 means 1 unit of model 1 gives me rupees 60 profit. Means if I talk about model 1, then this 1 unit on the sale of 1 unit of model 1, I will get rupees 60 as a profit. So obviously let x1 be the number of units of model 1. Similarly, x2 be the number of units of model 2 and x3 be the number of units of model 3 are to be produced. So these are my variables. This is very important thing, that you should identify these variables first, because unless and until you define the variables, we cannot go to the constraints. We should know for that what are the variables. So here we have defined now the variables. This is the first part. We have defined this from this line. So that's why you read the example till the end. Do not make your opinion, or do not think that okay, it should be like this. No, you first go line by line and go to the end of the example and read it properly, so that we can identify the variables. So here we have identified the variables. Now let us go to this first paragraph here. Now in this paragraph, some information about raw materials is given. So here we will try to put it in the form of table. So here raw materials, as we discussed in the previous lecture, that always when we collect the data in the tabular form, always the columns must be the columns of variables. And also yesterday we have done it, in the previous lecture we have done it, the table we have constructed already. So here my the variables are we have defined for models 1, 2 and 3. So obviously these are my columns. And now first I will define the raw material constraints. Here there are varieties of constraints are there, so we will think it one by one. So first I will talk about this raw material constraint. Okay, so let us put it try to put it in the tabular form. So see this table. Yes, this is the table. So in this table, here if you observe, columns are the variables. Actually, this is model 1, this is model 2, and this is model 3, which you can see in the pink color, shaded by pink color. And the variables are so given. Raw materials is the first column as A and B. Now, as per the information given in the example, we have substituted that values, that 2 units of raw material A and 4 units of raw material B is required to produce 1 unit of model 1. So here you can see this line. I will show you that the raw material requirements per units of model 1 is 2 units of A and 4 units of B. So that will be my first column. That is, first column should be 2, 4, which is there. You can see here it is 2, 4. Now for model 2, it requires 3 units of A and 2 units of B. So 3, 2 will be my second column. Yes, 3, 2 is my second column. And now for model 3, it requires 5 units of A and 7 units of B. At the same time, we will see here these figures. These are the availability of raw materials A and B. So let us go to the table again. So as per the given information in the example, we have constructed this table for raw material. Here availability for raw material A is 4,000 and raw material B is 6,000. So as this is availability, means maximum number of 4,000 and 6,000 units are available for raw material. So here this is just one additional column I have shown. It is not there in the example when you solve it, but as per here, for your sake of convenience for understanding, I have put the table here. So here, as availability means maximum number of availability, that 4,600 only available thing is available material, that much unit of available material is there. So you have this less than or equal to sign. So from this now immediately I can write two raw material constraints, means one constraint for raw material A and another constraint for raw material B. Let us see what are that constraints. Yes. So in this way, you have to write down the names also, that which what is means you are writing the constraints for what, whether it is for time, whether it is for raw material, whether it is labors, whether it is some power or some machines, that you have to mention if you can. It is not actually compulsory, but if you do it properly, then there will be no confusion. So from this table now, first two raw material constraints we have written here, that 2x1 plus 3x2 plus 5x3 means raw material A is required for model 1, 2 and 3, but the availability is 4,000. So here it is less than or equal to 4,000. Same way, the second raw material constraint is 4x1 plus 2x2 plus 7x3 is less than or equal to 6,000. So now here we got two raw material constraints. Now we have completed the first paragraph here. This paragraph we have completed. Okay. Now we will go to this next paragraph. Here some time related they are talking. The labor time of each unit of model 1 is twice of model 2 and thrice times 3 times of model 3. Means the relation between the time of model 1, model 2 and model 3 they have given. That is, if uh, let us discuss it afterwards. First, we'll complete this. The entire labor force of the factory can produce equivalent of 2,500 units of model 1. So here the availability of time is given. Same example we discussed yesterday also, that if the total time is given, then some it was talking about some hats, then that 250 or some number was given, 400 hats can be produced, can be manufactured. So same way, if the total time, available time is dedicated for model 1 only, then 2500 units of model 1 can be produced. So the total time here we will get from this sentence, and as here they are discussing about model 1, we have to define the time for model 1, and according to that we will find time for model 2 and model 3. So if we'll define that t is time for model 1, then here the sentence says that is twice of model 1 time. If it is t, then it is twice of model 2. So obviously time required to produce 1 unit of model 2 is t by 2, isn't it? Because if we'll double it, then we will get time of model 1 and 3 times of model 3. That is, time of model 1 is 3 times of model 3. So obviously, the time required to produce 1 unit of model 3 will be T by 3. So let us write down this constraint here. So first we'll define the time. So let the time required to produce 1 unit of model 1 be T, as they have given the availability of time for model 1. Here we will define the time for model 1. So let it be suppose t. So therefore time required to produce 1 unit of model 2 is t by 2, obviously, because model 2 requires twice the time of model 1. So therefore time model 2 time will be t by 2, obviously. Then time required to produce 1 unit of model 3 is t by 3, as model 3 requires 3 times of time as compared to model 1. So this is very important thing here which one can understand. One should understand this, that how we are defining the time. And here we, as we have given this, they have given the relation of model 1 with model 2 and model 3. They are not comparing each in sequence. They have given the relation of model 1 time with model 2 and model 3. So in this way, we will get time for model 1, 2 and 3 to produce 1 unit of their 1 unit. So now what is the total time? So they have said in the example that if total time is dedicated for model 1, then 2500 units are to be produced. So obviously for 1 unit, if it requires t time, then for 2500 units it requires 2500 into t. It means that the total time available is 2500 t. And now using this information, let us uh, define the time constraint. So we'll define the time constraint. So what is the time constraint now? Look at here. So again here the table is there. The variables are x1, x2, x3. Here actually whatever figures we put it in the table is per unit. And x1 is number of units. So therefore t is actually the time required to produce 1 unit of model 1. So always in the table put the figures per unit, right? So here this table gives me the actual information about the line, that is time required for model 1 for 1 unit is T, then T by 2 for model 2, then T by 3 for model 3, and total available time is 2500 T. So obviously the sign will be less than or equal to. So let us see what is the time constraint. So the time constraint is, first I will write it in the form of T. So it is T into x1 plus T by 2 into x2 plus T by 3 into x3 is less than or equal to, as it is available time, is less than or equal to 2500 T. So here T will get cancelled, and finally we will get the constant in the form of x1, x2, x3 as x1 plus x2 upon 2 plus x3 upon 3 is less than or equal to 2500. So in this way we will get the time constant. So first we talked about the raw materials. We got the raw material constraints there. Then now second paragraph was about time. So here we will get the time constant. Now let us go again, go back to this example and let us see. Now this is finished. In second paragraph we have already taken care. Now what this third paragraph tells me? This paragraph tells me about the demand. So here you should take care of this word, the minimum demand. Here the word is minimum demand. That is, this is the minimum number of units to be there in the market. So maximum can be any number. So obviously here, whenever there is demand, the examples which we seen in the first lecture, their demand was exact or maximum demand they had given, but here they have given minimum demand, that is at least 500 units should be there in the market. Maximum any number can be there. So obviously here for model 1, model 2 and model 3, this is the minimum number of units to be there in the market. So let us write down that demand constraint. So here it was a time constraint. Now here you see this demand constraint. So given that a market survey indicates that the minimum demand of 3 models is 500, 500 and 350 units respectively. That is 500 units are the requirement for model 1 units is 500 units minimum. It's the number is minimum. So let us, it's very simple constraint. Then the demand constraints are, as x1 is the number of units of model 1 and minimum requirement is 500. Then for model 1, the demand constraint is x1 is greater than or equal to 500. For model 2, it is x2 is greater than or equal to 500, and for x3 it is greater than or equal to 350. So now we have talked till the constraints of raw material constraints, then time constraint, and now demand constraint. But still there is more information in the example. Again we will go back to the example. So here is that information. What is this? However, the ratios of the number of units produced must be equal to 3:2:5. That is ratio of x1, x2, x3 must be 3:2:5. Then how to write it? Here, just see. Yes. So given that the ratio of number of units produced must equal to 3:2:5. That is x1:2:2, x3 must equal to 3:2:5. So how to write it? So in this way, that is x1 upon 3 equal to x2 upon 2 equal to x3 upon 5. So you can say this is like that direction cosines and direction ratios of the lines which you studied in your 5 BSc, because direction cosines and direction ratios of the line are proportional to each other. So same way here, these numbers 3 to 5 are proportional to x1, x2, x3. So from this now, how to get the equation? So from this now, if we'll make pair, then we will get first pair as x1 upon 3 equal to x2 upon 3 here, and next pair x2 upon 2 equal to x3 upon 5. So from this now I will get two more constraints. So which are that constraints? So these are my two constraints. So this implies 2x1 minus 3x2 equal to 0. and 5x2 minus 2x3 equal to 0. So now I think almost every information we have covered for this example. Look at here. So here initially the models they have given. Then this second paragraph is talking about raw material. We have written the raw material constraints. Then this paragraph is talking about the labor time. So we have written the time constraint also. Then now this third paragraph is talking about the demand. So we constructed that demand constraints also. And now lastly here it is talking about some ratio. So also we have constructed the constraints using this ratios. So now here last the profit here. So this will give me my objective function. So let us go to now objective function. So look at here, have a glance now. These are my raw material constraints here. These are my raw material constraints. Then this is my time constraint. Then these are demand constraint. And these are the ratio constraints. And now we will go to the objective function. So given that the profit per unit of models 1, 2 and 3 are rupees 60, 40 and 100 respectively. So obviously it is very clear the profit for model 1 is 60 into x1. For model 2 is 40 into x2, and for model 3 it is 100 into x3. So directly we will get this as an, so first we will write it as a total profit. That what will be the total profit? 60 x1 plus 40 x2 plus 100 x3. So now here everything we have discussed about this example. Now let us go to the LPP. So this is my LPP. So it's very big, but it is there which we have to do. So you can read this. So LPP is maximum. Anyways, so LPP, what is it? First, my objective function is what? Profit, total profit. So obviously, profit we have to maximize. So it is maximum Z equal to 60 x1 plus 40 x2 plus 100 x3. Then subject to this first two are my raw material constraints, which we have already constructed. This next one is my time constraint. Again, we have discussed about this time constraint. Then these next three are my demand constraints. We have constructed them, and these two constraints we have got from the ratio. And this is by default you have to write that as this x1, x2, x3 are the number of units, and we have discussed when we discussed the formulation that as this represents always the number of units to be produced or some units, it cannot be negative. So here by default last at the end of this LPP you must write the positivity constraint. So here this is the linear programming model